When XPENG unveiled the iron humanoid, the internet went wild. The robot moved so fluidly, so naturally, that people couldn't believe what they were seeing. It walked like a runway model, swayed its hips, gestured with its hands. Millions of comments flooded in. Fake, that's an AI video. The CEO had no choice. He brought Iron back on stage in front of 3,000 people and rolling cameras and did something no one expected. He told the engineers, "Cut it open." The blade pressed into iron. Synthetic skin peeled back like rubber. And underneath, no blood, no muscle, just motors, actuators, and an exoskeleton humming with mechanical power. The room went silent. This wasn't Westworld. This wasn't a stunt. This was real. So, how does a car company build something that fools millions of people into thinking it's human? Here's what they're not telling you. XPENG makes electric cars, but in 2020 they started a secret project to build a humanoid robot from scratch. By 2024, they had a clunky prototype that could barely walk. It stumbled over flat surfaces, dropped objects, learned one skill every few weeks. Then, the CEO threw $7 billion at the problem and everything changed. He became obsessed. He said building robots was way harder than cars because a car has one steering wheel and 4 wheels, but a humanoid has 82 joints that each need to coordinate like a human body. Every joint needs sensors, motors, control systems, and they all need to work together in real time without lag. But why humanoid? Because the training data already exists. Billions of hours of video showing humans walking, running, grabbing, balancing, and gesturing. YouTube alone has enough human movement data to train 1,000 robots. XPENG just had to figure out how to tap into it. The breakthrough came in 2025. XPENG switched to Vision Language Action 2.0. Instead of processing text instructions and translating them into movement, Iron sees an object, interprets it visually through computer vision, and acts immediately. This made the hardware revolution easy. Engineers added a bionic spine that allows hip rotation and torso twist. Movements that look simple but require complex coordination. Synthetic muscles made from elastomer lattices that mimic human muscle fibers. And the brain? XPENG's Turing AI chip, originally designed for autonomous vehicles to process sensor data from cameras, LiDAR, and radar in real time. Now it's processing humanoid movement, balance, object recognition, and decision making. But XPENG had another advantage nobody talks about. They control 60% of global robot components, motors from their EV division, sensors from their self-driving program, batteries from their energy research, actuators from their manufacturing partners. Everything about Iron was designed to fit seamlessly into human environments. Not because it's easier to build, it's actually harder, but because humans have already optimized the world for ourselves. If a robot can navigate our spaces, it can work anywhere. But integration is only half the story. What's actually inside Iron that makes it move like a human? November 5th, 2025, Guangzhou, XPENG AI Day. The moment Iron stepped onto that stage, robotics experts knew something had shifted. Iron stands 1.73 meters tall, weighs 70 kilograms, about the size of an average human adult. But the specs tell a different story. Iron has 82 independent joints. Your body has about 360, but Iron's 22 joint hand can thread a needle on the first try. Can you? These aren't normal motors. They're precision instruments that measure resistance in real time. Watch Iron make coffee. Iron finds the perfect grip in milliseconds. It can tie knots, thread needles, unscrew bottle caps, plug in USB cables on the first try. Tasks that seem simple but require an understanding of friction, torque, and spatial reasoning that most robots completely lack. 3 Turing AI chips power everything. Combined, they pump out 2,250 to 3,000 tops. trillions of operations per second, more than high-end gaming PCs, all packed inside a humanoid frame processing vision, audio, balance, and movement simultaneously. Meanwhile, the power source is solid-state batteries. Iron is the first humanoid to use them commercially. 30% lighter than lithium-ion, higher energy density, and critically, safer, no risk of fire or explosion. Iron can operate for hours without recharging, without overheating, without needing a team of technicians to monitor battery temperatures. However, vision is where things get truly advanced. Eagle Eye 720-degree sight, an array of cameras and sensors positioned around the head and torso creates a complete wraparound view. No blind spots, no need to turn its head to see behind it. The system processes depth, distance, and movement in real time. It can track multiple objects simultaneously, recognize faces, read text, identify obstacles, and it does all of this while moving, while the environment changes, while people walk in front of it. Spatial audio completes the picture. Microphones embedded in those human-like ears pick up sound from all directions. Iron can locate voices in a crowd, filter background noise, distinguish between a command and casual conversation. Those ears, by the way, sparked the whole controversy. People saw them and assumed they were human. They're not. They're acoustic sensors designed to look natural while serving a functional purpose. But the most controversial feature is the skin. It's not cosmetic, it's a functional interface. Touch-sensitive synthetic material that detects pressure, temperature, and contact location. Iron knows when it's being touched, where it's being touched, how hard. Engineers tested this by hugging the robot, shaking its hand, patting its shoulder. He Xiaopeng called it huggable because they wanted Iron to feel safe, not cold. Not mechanical, safe. The skin is customizable, different textures, different tones, male, female, slim, stocky. The female model has breasts, curves, feminine facial features. XPENG calls it comfort and relatability. Critics called it something else. They called it objectification, said it reinforces gender stereotypes, opened ethical nightmares about consent, intimacy, and how humans might interact with human-like machines. XPENG responded that they're just matching what people expect from service roles, flight attendants, retail workers, hospitality staff, industries where appearance matters to customers. The internet had turned a factory robot into something else entirely, and it raised questions XPENG couldn't easily answer. If a robot looks human, acts human, and feels human to touch, where do we draw ethical boundaries? But while the internet argues about robot ethics, Iron clocked in for its first day of work. At XPENG's Jiaoqing manufacturing facility, Iron works the assembly line. It does vehicle quality checks, inspects welds, measures panel gaps, checks paint finishes, tasks that require precision and consistency but bore human workers to tears. The factory runs more efficiently with Iron on the floor. Downtime decreased, defects dropped, and human workers moved to supervisory roles instead of repetitive inspection tasks. Baoshan Iron and Steel is testing Iron for fault detection in their mills. Steel production involves extreme temperatures, heavy machinery, and hazardous conditions. Sending humans into some areas risks injury. Sending Iron, no risk. If something goes wrong, you repair or replace it. Early results show Iron catches equipment faults earlier than human inspectors. It processes thermal imaging data, vibration patterns, and acoustic signatures simultaneously. A bearing that's starting to fail sounds different, runs hotter, vibrates at a different frequency. Iron detects these micro changes before they become macro failures. But factories are just the beginning. By late 2026, XPENG plans to put Iron in retail stores. Their own stores first, then partnerships with other brands. This means when you walk into a store, Iron greets you at the door, answers your questions, never takes a break, never has a bad day, never asks for a raise. The human sales associate who used to do that job, gone. Not because they were bad at their job, because iron costs significantly less than a human. 5 to 10 years out, XPENG targets healthcare, home assistance, elderly care. China has a demographic crisis. The population is aging rapidly, and there aren't enough young people to care for them all. Iron could help. Remind patients to take medication, assist with mobility, monitor vital signs, call for help in emergencies. And we're not even talking about home assistance. A robot that can do laundry, clean, cook, organize, and respond to voice commands. Amazon's been chasing this for years with Alexa on wheels. Apple wants it, Google wants it. Everyone wants a home robot that actually works. XPENG thinks iron is the answer. The dexterity, vision, and AI are all there. What's missing is the software ecosystem. That's why they're opening an SDK. Let developers build apps, create new behaviors, train iron for specific tasks. It sounds like science fiction, but the technology exists today. What's missing is refinement, testing, debugging, and scale. Speaking of scale, XPENG's production plan is aggressive. Mass production starts in late 2026. By 2030, they want to build 1 million humanoids per year. For context, Tesla delivered about 1.8 million cars in 2023. XPENG wants to hit half that number in humanoid robots by the end of the decade. This is where the economic implications become unavoidable. If iron succeeds, if XPENG hits those production numbers, entire job categories disappear. Retail workers, factory inspectors, warehouse staff, security guards, cleaning crews, home health aides, delivery drivers, customer service reps, all gone. But XPENG isn't alone in this race. Tesla, Boston Dynamics, and a dozen other companies are building their own versions. The question is, why does iron look so much more human than any of them? Tesla's Optimus, still shuffling around like it's wearing a spacesuit. Impressive for early development, not ready for prime time. Boston Dynamics Atlas is the showstopper. Backflips, parkour, running over obstacles. It's built for strength and agility. Engineers love it, but Atlas isn't designed for human interaction. It's industrial, built for construction sites, disaster zones, and military applications. No friendly interface, no soft skin. It's a tool, not a companion. How about Unitree's H2, a Chinese competitor priced at $30,000? Affordable, capable, but nowhere near as advanced as iron. Basic dexterity, limited AI. It's a budget option for simple tasks. Iron sits in a different category entirely. Most human-like gait in the industry. Soft, touch-sensitive skin that makes physical interaction natural. Solid-state batteries that are safer and lighter. Massive on-device comp in actual factories doing actual work. The projected price? Under $30,000 based on XPENG's component costs and manufacturing scale. That puts it in the same price range as a new car. Cheaper than Unitree once you factor in capabilities, a fraction of Figure 1's cost. Western robots look mechanical. You can tell they're machines, industrial, functional, obviously robotic. But now we have to answer a very uncomfortable question. What happens when humanoids become normal? When they're affordable enough for small businesses? When they're everywhere? You won't just compete with software for jobs. You'll compete with physical beings that move like you, think faster than you, work longer than you, and cost less than minimum wage. A retail worker in the US earns maybe $30,000 a year. Benefits add another $10,000. That's $40,000 annually. Iron costs $30,000 once, then electricity and maintenance, maybe $5,000 a year in operating costs. Break-even happens in under a year. After that, pure savings. Scale that across industries. McDonald's has 200,000 employees. Replace half with humanoids and you save billions annually. Walmart employs 2.1 million people. replace just 10% with humanoids, that's 210,000 jobs gone. This isn't speculation, it's arithmetic, and the economics are too compelling for businesses to ignore. What do displaced workers do? Retrain? For what? AI is getting better at knowledge work too. Robot humanoids handle physical tasks. Large language models handle cognitive tasks. What's left? Some argue that new jobs will emerge. They always have before. The Industrial Revolution eliminated farm jobs, but created factory jobs. Computers eliminated typing pools, but created software jobs. But this feels different. Both physical and cognitive work are being automated simultaneously. The transition might happen too fast for society to adapt. Others argue humans will move to creative, emotional, and social roles. Jobs that require empathy, judgment, and human connection. Therapists, teachers, artists, managers, maybe, but how many of those jobs exist? Enough to employ hundreds of millions of displaced workers? And are those jobs safe? AI art tools already threaten illustrators. AI writing tools threaten copywriters. AI tutors are getting better every year. Even emotional labor might not be safe. If iron can read facial expressions, modulate its voice, and respond with appropriate empathy, can it do customer service, counseling, coaching? The line between human only and robot capable keeps moving, and it's moving fast. For China, humanoids are strategic. They're not just about corporate profits. They're about maintaining economic growth as the population ages. For the West, humanoids are disruptive. They threaten employment, challenge labor laws, raise uncomfortable questions about inequality and who benefits from automation. If iron succeeds in China, Western companies will face pressure to adopt similar technology or lose competitiveness. A Chinese manufacturer using humanoids can undercut a Western manufacturer using human labor. The race is already on, and right now, China is winning. So when iron walks into a store near you, when it greets you with a smile, when its synthetic skin feels warm to the touch, when you forget for just a second that it's not human, ask yourself, what happens when the robots don't just take our jobs, they take our faces too? XPENG's CEO grins when asked about the future. The future is physical, he says. Judging by the 30 million views, the death threats, the fan art, and the conspiracy theories, that future is already here, and nobody knows what to do about it. Still, iron isn't the only humanoid coming for your job. 7 more companies are about to flood the market in 2026, and one of them makes iron look outdated. Click on the next video to see new humanoids coming out in 2026.